Hello everyone. Warm welcome to this final module, which is all about summarization of what we have learned in the entire course. So this is basically a beginner level recap for the students. If you are beginners, how and what you have learned. So I welcome you all in this session and we'll walk through the entire crash course on machine learning from understanding core concepts to building a real world models using tools like scikit-learn, TensorFlow, Keras, and with this presentation in your comprehensive recap which you will be getting. Whether you are a complete beginner or someone who is looking to strengthen your foundation, this summarization is for you. So, throughout the entire segment, you all being very patiently, you were doing all the hands on practices, everything I have included in this particular session. So, we are going to go through quick recap of each and every module which you all have covered in this particular session. Before I go ahead with it, let me quickly share with all of you that this course, which we have just like done, one final module, which I am going through today. By the end of this module, we will be creating a mini model also, which is of machine learning. And then we are going to finish this entire course. I hope you have enjoyed it. Keep sharing your views with us. And let's quickly get started in the entire course, the module number one, which we have completed, that was Introduction to Machine Learning. We started with understanding what machine learning really is. It's all about teaching machine to learn from data. All right. We explored three types of machine learning, whether it was supervised learning, where we train using labeled data, unsupervised learning, where the model finds hidden patterns, and reinforced learning, where model learn by trial and error method. We also looked at real world use cases from span filtering or to self driving cars and followed by general machine learning workflow, which was all about how you are going to define the problem. Then you have to gather the data, then you are going to train your model, and ultimately you are going to evaluate the performance of your model. Basically, we have done this hands-on practice on teachable machine. That was where we created our first model with three types of different models which we created, starting with image project. Then we created by using audio project. Thereafter, we started and we created on pause project. We have taken data through webcam, or you have I have shared with you how you are going to download the data set from Google and you are going to map that. There you needed to make sure that there are certain things which is going to impact your machine learning model, which was first number is that you are going to fetch the data set, and your data set must be clean. Make sure the data which you are taking, it is clean. There is no null values or there is no external factors which are impacting. The data which you must be taking, it should be in abundance, because more number of data is going to bring more, you can say, more values to it and more accuracy it is going to provide. So with that, let's quickly move to our second module which we completed, that was data preparation for ML models. Before training any model, preparation is needed, or preparing the data is crucial. We learned how to scale numerical features, encode categorical data, and handle missing values. We also divided data sets into training, testing, and validation sets to ensure reliability of that model evaluation. A big challenge was handling the data imbalance, for instance, in medical data sets where one class is, you can say, underrepresented. We explore techniques to handle that as well. So, that we have done in the last model which we created, it was finding whether the person is diabetic or not. Using TensorFlow, we have created multiple layers. Dense layer was there, output or you can say dropout layer was there. So these were all how you are going to calculate it. And we have scaled that model also. X we scaled, X test as well as X train. It was all about how you are going to prepare your data, right? Now, let's quickly move to our module number 3. Module number 3 was all about how you are going to run the classification algorithm. When we talk about classification, about algorithm, how it is going to be done, in this module, we dealt with classification problems where it says predicting categories like yes and no, or diabetic or non-diabetic, or we use algorithms like logistic regressions, decision trees, and k nearest neighbor, which is KNN. We saw how to fit models, make predictions, and access, or you can say assess the performance using accuracy, confusion metrics, and decision boundaries. These visual tools helps us to interpret how the model makes decisions. These are the things in the last model. If you remember, I have from the scikit-learn, I have imported all these accuracy segment to show you that the model which we created, it was of 56% of accuracy. There I called upon confusion metrics as well as ROC and AUC. So that is what we have done in the last particular session and the model which we created. Basically, when we talk about classification, classification means what sort of mathematics is behind that model, how the logistic regression or what kind of regression is there. And it depends on the output which you want. If you want an output where you wanted to just classify which species is of dog and which is of cat, then you are going to run after scalar vector model, which is SVM. So there are particular models. When you are going to practice, you are going to learn more about it. So keep practicing, everyone. Now let's quickly move to our module number 4, which was all about regression. Here we focused on predicting continuous values such as salary, rent, or marks. We begin with linear regression and move to polynomial regression or more complex regression methods or relationships. We measured performances using MEA, which was mean absolute error, and RMSE, which was root mean square error. And we learned how to interpret regression coefficients. We also discussed overfitting and how you are going to avoid it using techniques like regulations. So these are all things which we have done continuously in all the models which we created. Because if you wanted to create any model, you cannot just do one thing and it is created. You have to focus upon each and every part of it, and then only one model you will be able to create. However, if you are going to check, when we started, the level of difficulty of creating model was this, and then it has increased step by step, right? We started using Python methodologies and you can see different libraries to make sure that your data interpretation is going to be good and accurate. With that, let's move to our next module. So here we have learned regression, how different regressions are going to work. We have taken two aspects. One was income prediction. So first part, which where we have taken income prediction with only one column. One is input and the output. Thereafter, later on, I have shown you how you can convert this linear regression into multivariate regression. That was basically by putting different inputs and getting one output out of it. So this is what we have done, and that is what the regression techniques is going to be varying, and where you are going to use MAE and RMSE to make sure that accuracy is good. Next, module number 5, it was all about how you are going to use neural network. This was our first step into deep learning. As I have already shared with you, deep learning is a subset of machine learning. We explored how a neural network works. Input layer, that was the first layer, which is our data. Then it goes into the processing part, which was hidden layers. And ultimately, you get your output via output layer. We discussed key components such as activation functions, where we have used ReLU and sigmoid. We have understood loss functions, which was MSE or cross entropy. We have understood optimizers like ADAM or SDG, as well as we have understood how you are going to use TensorFlow and Keras. We built and trained a simple neural network model on structured data like CSV files. And throughout the entire segment, we have used only CSV file. I have shown you how first you are going to create your data on Excel and how you are going to convert that into CSV. In between, I have shown you how you are going to interpret the data by analyzing within Excel sheet, right? So that before you land onto any model, you should know what patterns this data is creating. What exactly are the inferences which you are going to calculate in this particular model? When these models which you will be creating, those are enhanced one, and you know that these kind of outputs, or these are the relationships, or these are the dependencies which you are going to cater into, you are on a good track. So these are all steps which we have taken when we come to module number 5. In fact, when you are going to link all the modules, step by step, you can link. But throughout the session, in each and every module, or in each and every model which we have created of machine learning, throughout you have used all these steps. I have just explained all those by enhancing the difficulty, you can say, starting from the beginner to intermediate and to advanced. That is what I have done with machine learning models. You must have seen and experienced that. Let's move to our module number 6, which is all about how you are going to use auto ML, which is machine learning, which makes machine learn more accessible by automating model creation. We explored Azure Machine Learning Studio, which allows drag and drop model building by using pipelines. You can use Google Auto ML as well. These platforms automatically select features, choose algorithm by themselves, and evaluate model, which is ideal for those who are non-programmers and who are very new to machine learning. But basics and fundamentals needs to be clear. So that's why we have kept it as module number 6, where you know what exactly are going to be the step, because if you don't know the step, the flow is not going to be created for you. Therefore, those steps are very, very important, and how you are going to put and what you are going to put. You cannot do any analogies or things without splitting the data, right? You have to call upon split data into test and train. Then you are going to take the decision tree, whether you will be taking any regression or decision tree. So those classifications are at must. You can take on ad hoc basis also. You can calculate it and you can see which one is going to bring you the best outcome, which is going to bring you the better accuracy, that you can choose your own. So you can take any sample data and you can get started the way we have done in this module or in this session. I hope you remember and you have practiced it. Let's quickly move to our module number 7, which we have just completed in the previous class. In module number 7, we have done building a model is only half the work that we were doing previously. We were cleaning the data. However, most of the data which I have shared with you, that was almost the clean data which I shared, right? Evaluating it is equally important. Because without evaluation, your accuracy and your client, if you wanted to share it with your client and your client has shared that he or she want this kind of machine learning model, then this is a very crucial step. For any kind of classification, we used accuracy, perception, we recall, and F1 score. We also explored ROC, curves, as well as AUC. Why we have done that? To find the accuracy, to understand the true positive or false or positive trades off. For turning, we used cross validation and hyperparameter. For optimization, we have used to improve model performance and to avoid overfitting. We have also understood how dropout layer is going to work to make sure that your model is avoiding overfitting. Here also, we have understood what is the role of overfitting as well as what is the role of underfitting. So these are the things which we have done, and the model which we created, it was find out or predict whether the person is diabetic or not by taking four multiples or inputs in which it was age as well as we had taken BMI, glucose level, as well as, so these are all things which we have taken. Considering all these things, we cater to a conclusion whether the person is diabetic or not. So that was our output. So basically, considering all of these, we have done the evaluation, and our major focus for this particular module was how you are going to run the evaluations in it, because evaluation is the most important part when you are creating. And therefore, after the evaluation, the model which comes, it shows the accuracy of it. If you have not understood, go through the video, watch it again, and follow all the steps which we have covered. Thereafter, let's move to the next one. Here, this is module, or you can say module number 8. This was actually the capstone model. We have applied everything, and now we are going to see how you are going to create a model by your own. And in today's session, what we are going to do, we are going to apply all the things, starting defining the problem, then collecting it and prepare data, training the model, as well as evaluating it using matrices. Finally, we are going to save and deploy the model using TensorFlow saved model. This is exactly how it works in the real world of workflows. So that is what we will be doing in today's session. So stay tuned with me. Thereafter, I'm going to just show you how and what sort of models which we have created. Throughout the entire course, we built several real world projects such as income prediction based on experience and education. Second model which we created, student score prediction, in which we have taken students like how much hours they have studied and how scores they have received. As well as we have understood, we created multivariant also where students were like taking TOEFL score as well as GRE, and how a heat map is going to show the correlation and dependency. Thereafter, we have created a multivariant which was car resale estimation using make model or mileage. Thereafter, we created house rent prediction using city, BHK, which is the area, as well as the last model which we have created, it was diabetes prediction using health indicators. These projects helped us to apply theory in practice and gain hands on confidence. I hope now you are at a stage where you can put all these modules in your resume to grab the attentions of the employer. Basically, if you get the in depth knowledge of each and every module or hands on project based on ML which you have created, definitely no one is going to stop you. So this is what we have done throughout this entire course. Therefore, would like to share once again just a kind of recap what tools and libraries you have used by creating all these modules. We have used an entire ecosystem of tools. We have used scikit-learn library for model building. We have used TensorFlow and Keras for neural networks. We have used Pandas and NumPy for data handling, as well as we have used Matplotlib and Seaborn for data visualization. All these are industry standard libraries that power most machine learning applications in today's world. Basically, without them, you cannot create any machine learning. So, do remember whenever any employer or interviewer asks you what is the role of scikit-learn, what is the role of TensorFlow or Keras, what is the role of pandas and numpy or matplotlib or seaborn, you are now aware of and you have done hands-on practice on all these libraries and tools. So this is the major focus of this entire session. Now let's move to the last slide of today's session, and then we are going to get started with our hands-on practice. We can't This was all about like how you are going to get an understanding of this entire model matrices. We can't improve what we can't measure. So for regression, we used MAE and RMSE. For classification, we used accuracy, perception, recall, effort force, and we also visualized the result using confusion metrics. ROC curves. Matrices helps us to know when the model performed well and when it is needed to be improved. So this was all about the evaluation part. And thereafter, it's not like that there are no challenges. We have faced certain challenges also. Along the way, we face common challenges like data imbalance, especially in classification problems. Overfitting, models perform well on training data but poorly on testing data. Feature selection, choosing the right inputs for better accuracy, but we resolve these using techniques like regulations, resampling, and proper validation splits by using random state, by using scalar standards. So these are all measures which we have taken to make sure that the accuracy is going to be there. And we are going to make sure that overfitting and underfitting is not going to be an issue. Now, with that, let's move to the next one. Here, machine learning is not just theory. All these models which you have created, it is just starting. It powers the tool we use every day, whether it is healthcare, predicting disease, or risk that we have done by putting a diabetic one. Finance like fraud detection, credit scoring, which you can create by your own. E-commerce recommendation system like smart assistants like Alexa and Siri. This shows how your learning connects directly with industry needs. So I have given you certain hints with which you can create and you can prepare your own model. Now, what are going to be the next step in your machine learning journey? This is just the beginning, everyone. Next step for you could be exploring advanced machine learning models like random forest and SVM, diving into deep learning, or you can say natural language processing, participating in Kaggle competitions to solve real problems. Every time to create a Kaggle account, there in the community, there are competitions going on. If you are going to participate in that, I think you will be able to enhance your knowledge of machine learning. Building a strong machine learning portfolio in GitHub, that is going to be the next step, and you'll keep on continue building, keep experimenting, and never stop learning. So these are all steps which I want from all of you. By the end of this entire course, I hope you have taken this seriously and you are practicing, because I have put in a lot of efforts to make sure that I'm going to bring the best for you, and you are going to take it forward. You all are going to be machine learning engineers or data science engineers. Best of luck to all the aspirants and keep learning. In case if you have any doubt, there are several platforms from where you can take help and you can write to us. Definitely, we are going to provide our help and support to you. With that, let's quickly move to our hands-on practice, which is based on our today's session, and we are going to create a mini model of machine learning, and there you are going to understand how it is going to work. So for that, be ready with your Google Colab because we will be using Google Colab for that, and stay tuned and keep learning. Thank you, everyone.